going to discuss an important topic, circles. By the end of this session, you will learn definition of the circle and related terms, arcs and segments of the circle, angle subtended by a chord. We are going to learn perpendicular from the center to a chord and circumcircle, and also we learn angle subtended by an arc of a circle. Cyclic quadrilateral. Observe the figures: Earth, Ashoka Chakra, CD, coins. So, what is the common thing in these, students? So, these are all circular objects. Now, let us see this. This is a bangle. With the bangle, circle is drawn. So, what is this, students? Outline along the edges of a bangle form a circle. Now, tell me, what is the difference between the circular objects and the circle? All the circular objects we have observed above have thickness and are three-dimensional objects, and in the same way, whereas a circle is a two-dimensional figure with no thickness. Let us take another example of a circle. So, you might have seen the oil press called oil mill. So, this is called Spanish wheel, or in Telugu we call it as Ganuga. So, in this what happens is, a line along the boundary made by the bullock is a circle. The oil press is attached to the ground at a fixed point, which is the center of the circle. The length of the fulcrum with reference to the circle is radius of the circle. Now, students, make any 5 points A, B, C, D, E on the circle. So, this is the circle. The points are A, B, C, D, E. Join these points OA, OB, OC, OD and OE. So, the length of each line segment OA, OB, OC, OD and OE is 5 cm, which is equal to the radius. Mark some other points on the circle and measure their distances from the point O. So, if you mark any other points like this, measure their distance. What have you observed, students? So, we can say that a circle is a collection of all the points in a plane which are at a fixed distance from a fixed point on the plane, and the fixed point O is called the center of the circle and the fixed distance OA is called the radius of the circle. So, what we can say, students? A circle is a collection of all the points in a plane which are at a fixed distance from a fixed point in a plane. The fixed point O is called the center of the circle and the fixed distance is called the radius of the circle. Next, let us see. This is a circular park. So, in a circular park, Sahishnu is a student who started walking from a point around the park and completed one round. So, he started from here and he completed one round. Then, what do you call the distance covered by Sahishnu? It is the total length of the boundary of the circular park and is called circumference of the park. So, the complete length of a circle is called the circumference of the park. Now, do the following activity. Mark a point on a sheet of paper, taking this point as a center with any radius and draw a circle. Now, increase or decrease the radius and again draw some more circle with same center. One point we mark here and with taking some radius we have drawn a circle. Now, increasing the radius and drawn one more circle, and now decreasing the radius and drawing one circle from the same point. By increasing radius one more circle and increasing radius one more circle. So, we have drawn 5 circles with same center but different radius. So, what do we call these circles? What do you call the circles obtained in this activity? So, these circles are all called concentric circles. Circles having a common center are called concentric circle. Now, let us see congruent circle. What are the congruent circles? The congruent circles are these 2 circles we are having with a different center but same radius. So, circles having same radii but different center is called congruent circles. What happens if same center and same radius? The circle with same center and same radii are called as coincident circles. So, we have seen congruent circles, concentric circles and coincident circles. Now, let us see circle and plane. So, this is a circle and this is a plane. So, this circle divides plane into 3 different parts. A circle always divides the plane into 3 parts: inside, or interior of the circle. So, this total part will be inside or interior of the circle, and second one on the circle, or we can say or circumference, and the third one is outside or exterior of the circle. So, if I take a point A which is inside the circle, B this is also inside the circle, and if I take C and D both are on the circle, and E and F are the points exterior of the circle. Now, chord and diameter. What is a chord? Chord is nothing but the line segment joining any two points of the circle is called the chord of a circle. How many chords we can draw to a circle? We can draw infinite many chords to a circle. So, this is a 2 points P and Q. Here PQ is a chord. So, what is the longest chord? The diameter of a circle is the longest chord of a circle. So, the diameter of the circle is the longest chord of a circle, and we all know that always diameter is equal to 2 times of radius. What is the diameter? The chord passing through the center of the circle is called the diameter. Now, let us see what is the arc and segment of a circle. So, this is a circle, A is a point on the circle, B is a point on the circle. So, AB is a part of a circle. So, AB is a part of a circle which we call it as a arc of the circle. We can say this is a and B. In this figure, 2 points A comma B are on the circle, and they are dividing the circumference of the circle into 2 parts. So, one AB is a one part and downside is one more part. So, we can say the part of the circle between any 2 points on it is called an arc. Here AB is called an arc and it is denoted by AB. This is the symbol for arc. Now, let us see, this is a circle and AB is a diameter, A and B are end points of the diameter, and C is a point. If the end points of an arc become the end points of a diameter, then such an arc is called a semicircular arc. So, here ACB is a semicircular arc. If I take a point here as D, ADB will also a semicircular arc. So, a circle divides into 2 equal semicircular arcs. Now, O is a circle and A is a point on the circle and B is a one more point on the circle, then AB will be minor arc. If the arc is smaller than a semicircle, then the arc is called a minor arc. So, here if the arc is longer than a semicircle, then the arc is called a major arc. So, now we have seen 3 types of arc. One is a semicircular arc, minor arc and major arc. So, that depends on the size of the arc. So, in this figure AB is a minor arc, and if I mark a point C here, ACB will be minor arc, and if a point D is here, ADB is a major arc. So, in this circle ACB is a minor arc and ADB is a major arc. O is the center of the circle and AB is a chord. Now, let us see what is the segment of the circle. AB is a chord which divides circle into 2 parts. One is a minor segment. What is a minor segment? If we join the endpoints of an arc by a chord, the chord divides the circle into 2 parts. One will be minor and one will be major. This is a major segment and this is a minor segment. If it is a minor arc, the segment will be minor segment. If it is a major arc, then the segment will be major segment. The region between the chord and the minor arc is called the minor segment, and the region between the chord and the major arc is called the major segment. If the chord is a diameter, then the diameter divides the circle into 2 semicircular segment. Next, what is a sector? Sector is nothing but this is a circle and OA and OB are 2 radius, and this is a major sector and this is a minor sector. The area enclosed by an arc and the 2 radii is called a sector. If the arc is a minor arc, then the sector is called minor sector. If the arc is a major arc, then the sector is called the major sector. So, always we can say the area enclosed by an arc and 2 radii is called a sector. Now, let us see angle subtended by a chord at a point on the circle. In this we are having 3 cases. First one is angle at a center of the circle, angle at a point on minor arc, angle at a point on major arc. Now let us see each and every case, and the first case is angle subtended by a chord at the center of the circle. So this is the circle and two radii OA and OB are radii, and AB is a chord here. Now AOB is an angle made at center. OA and OB are radii. Now let A comma B any 2 points on a circle with center O, join AO and BO. Angle is made at center O by AO and BO. Then the AOB, angle AOB, this is the angle which is called as the angle subtended by the chord AB at the center O. Now angle subtended by a chord at the point on the major arc. Now see, this is the circle, PQ is a chord, R is a point on the major arc. So PQ is a chord here and R is a point on the major arc. Now PQ is a chord, R is a point on major arc. The PRQ is called the angle subtended by the chord PQ at the point on the major arc. Now angle subtended by a chord at the point on the minor arc. Now this is a minor arc, PQ is a chord, the same chord, and PQ is a minor arc, S is a point on the minor arc. Now PSQ will be the angle. Now let us see, PQ is a chord, S is a point on minor arc, then PSQ is called the angle subtended by the chord PQ at the point on the minor arc. Now angle subtended by a chord at a point, let us see all together once. Now PQ is a chord and this is the angle on the minor arc, and this is the angle on the major arc, and this is the angle at the center. Now PQ is a chord, POQ is called the angle subtended by the chord AB at the center O, and this is the angle POQ, this is the PRQ, angle subtended by the chord PQ at the point on the major arc. And third one is angle PSQ is called the angle subtended by the chord PQ at the point on the minor arc. Now observe student this one, circle, PQ is a chord and RS is also a chord. So in the figure, O is the center of the circle, PQ and RS are the chords of the circle. So we can observe PQ is a greater than RS. Then what happens, that is angle POQ is a greater than angle ROS. The angle subtended by the chords at the center of the circle increases with increase in the length of the chord. That means if the length of the chord increases, the angle also increases. If the length of the chord decreases, the angle also decreases, right? So what will happen to the length of angle if two chords are equal? Now what we can say is, the equal chords of a circle subtended equal angles at the center. That means if the length of the chords are equal, the angle also equal. So this is the circle. Let us prove this theorem. Circle with center O, AB is a chord and CD is also chord, and both the chords are in equal length. Now let us prove this theorem. What is given? Let O be the center of the circle, AB, CD are equal chords. Angle AOB, COD are the angles subtended by the chords at the center. AOB is called angle subtended by chord AB at center, and COD is the angle subtended by the chord CD at the center. Now what we need to prove? We need to prove angle AOB is equal to COD. These two angles are equal. We need to show that. We have to prove angle AOB is equal to COD. So for proving, in triangle AOB and triangle COD, AB is equal to CD and OA is equal to OC, because both OA and OC are radii of the same circle. OB is equal to OD. That means three corresponding sides are equal. We can say by SSS rule, side rule, triangle AOB is a congruent to triangle COD. So therefore angle AOB is equal to COD. So what we can conclude? Equal chords of a circle subtends equal angles at the center. Now converse theorem. So what is the converse theorem? If the angles subtended by the chords of a circle at the center are equal, then the chords are equal. So what we can finalize? If the chords are equal, if the angle made at the center is equal, then the chords are equal. So first let us see theorem. The perpendicular from the center of a circle to a chord bisects the chord. If you see this one, this is a circle with center O and chord, and OP is a line and AB is a chord. We have to show AP is equal to PB. What we have to prove? PA is equal to PB. So for this, first we need to construct OA and OB so that OAP and OBP triangles will be formed. So construction OA and OB. In the proof, in the triangle OPA and OPB, in these two triangles, how to prove OPA and OPB congruent? In this, I can say OA is equal to OB, both are the radii of the same circle, so these two are equal, and also OP is equal to OP, OP is the same side, APO is equal to OPB, which is equal to 90. So therefore by RHS rule, we can say OPA is congruent to OPB. Therefore AP is equal to PB by CPCT. Okay. Next, collinear points. If three or more points lie on the same line, then the points are called collinear points. So if you observe the points here, this is a points A, B, C. 3 points are lying on the same line, then we can say these 3 points are collinear points. A, B, C are collinear points. Let us see the circumcircle. There is one and only one circle that passes through 3 non-collinear points. Let us see what is the circle we call it as. Suppose AB is a line and C is another point which is a non-collinear point. So we can say A, B, C are non-collinear points. Then join AC and BC so that the triangle will be formed. So for any 3 non-collinear points, we can say one triangle can be formed. Now this is a circle which is passing through the 3 vertices of the triangle. Then this circle is called circumcircle. All the vertices lie on the same circle, then the circle is called circumcircle of the triangle. So once again let us see the definition. If 3 vertices of triangle lies on the circle, then the circle is called circumcircle of the triangle. 3 vertices of triangle lies on the same circle, then the circle is called circumcircle of the triangle. Now let us see, the center of the circle O is called circumcenter and the radius of circumcircle is called circumradius. O is circumcenter and OA or OB and or OC is called circumradius. Now let us see construction of circumcircle. Example, construct a circumcircle of the triangle ABC where AB is equal to 5, B is equal to 75 and BC is equal to 7 centimeter. That means first we need to construct a triangle with the given measurements. Then for the triangle passing through all 3 vertices, we need to draw a circle which is called circumcircle. So construct a circumcircle of the triangle ABC where AB is equal to 5 centimeter, angle B is equal to 75 and BC is equal to 7. For this we need to write a construction steps also. So what is the first step? The first step should be draw a line segment AB is equal to 5. Triangle first. So for the triangle AB is equal to 5, let us take AB is equal to 5 here. Draw a BX. So from B draw BX such that angle B is equal to 75. That means from B take angle 75, then draw a line which we call it as BX. Where B is at B, angle is 75 degrees. So draw BX at B such that the angle B is equal to 75. Now next, from B as center, draw an arc with radius 7 centimeter. Now join AC and call it as C. Join AC. So if you join AC, then triangle ABC is formed. So observe here ABC. So angle B is equal to 75 degrees and also now draw perpendicular bisector PQ to AB. So after drawing triangle, draw perpendicular bisector to AB and BC. First I am drawing perpendicular bisector from A. from A more than half, and from B with the same radius cutting the previous arcs. So if you join these 2 points, joining these 2 points, which is a perpendicular bisector of AB. So for perpendicular bisector from A more than half and joining these 2, and PQ is a perpendicular bisector of AB. Now let us draw perpendicular bisector of BC. So for that also from B more than half, draw 2 arcs. Same way from C, cut the previous arc with the same radius, cut the previous arc. So let us join RS, joining RS. So this is the RS, and if you observe PQ and RS joining at a point and take this as center, OA or OB or OC, you can take any radius. Now I am taking OA as radius, drawing a circle, and this circle is called circumcircle. Now let us see chords and their distance from the center of the circle. The congruent chords in a circle are at equal distance from the center of the circle. Let us see now, AB is a chord, also CD is a chord, both are congruent chords. OP is equal to OQ, equal length from its center. Chords of equal length are at equal distance from the center of the circle. Let us see one example based on this. In the figure, O is the center of the circle. Find the length of CD if AB is equal to 5. Solution: in triangle AOB, COD, OA is equal to OC, OB is equal to OD, and also given angle is same, AOB and COD angle given as 55 degrees. So 2 sides equal and included angle is equal, then by SAS rule 2 triangles are congruent to each other. Triangle AOB is a congruent to triangle COD. Now we can say AB is equal to CD. So AB we are having 5 centimeters, right? Then CD also 5 centimeters. Now let us see angle subtended by an arc of a circle. So if you observe, this is a circle, AB is a chord and this AB is an arc. In the figure, AB is a chord and AB arc is an arc. The endpoints of chord and arc are the same. Therefore, the angle subtended by the chord at the center O is the same as the angle subtended by the arc at the center O. Now let us see arcs of equal length subtends equal angles at the center. AOB is equal to COD because arcs of equal length subtends equal angle at the center. Now angle subtended by an arc at a point on the remaining part of the circle. Figure 1, figure 2 and figure 3. So what is the difference between these 3 figures? And first figure is this PQ is a minor arc, and if you observe, this PQ is a semicircular arc, and here PQ is a major arc. PRQ we call it as angle subtended by PQ at the point R, or we can say this is the other part of the circle. POQ is the angle subtended by the arc PQ at the center. Now POQ is equal to 2 times of PRQ. The angle subtended by an arc at the center O is twice the angle subtended by it on the remaining arc of the circle. As x, then what is the value of this? This value definitely that twice of the x, so 2x. If I take this is a 180 degrees and PRQ is a 90 degrees, we know that this angle subtended by semicircle. So observe here, if this is 100 and this will be 50. Based on this, let us solve this. Let O be the center of a circle, PQ is a diameter, then prove that angle PRQ is equal to 90. We can also say prove that angle in a semicircle is right angle. Let us see how. It is given that PQ is a diameter, then POQ is a 180 degrees. Now POQ is equal to 2 PRQ. Why? Because angle subtended by an arc at the center is twice the angle subtended by it at any other point on the circle. So we can say PRQ is equal to, this is 180, so we can write 180 by 2, which is equal to 90 degrees. So we can say angle in semicircle is a right angle. Find the value of x in the adjacent figure. So in this figure, this is x and this is the 40 degrees. Now find out the value of x. Let us see. Given ACB is equal to 40 degrees, we know that angle subtended by an arc at the center is twice the angle subtended by it at any other point on the circle. And right, AOB is twice ACB. AOB is equal to 2 into ACB is given as 40 degrees, 2 into 40 is 80 degrees. So AOB is 80. Now we got AOB, but what we need? We need to find out the x value, because we know angle x plus angle AOB is equal to 360 degrees, because it is a complete angle which is equal to 360 degrees. Therefore x is equal to 360 minus 80, which is equal to 280 degrees. Now let us see angle in the segment. Consider a circle with center O and a minor arc AB. Let P, Q, R, S points on the major arc. Now joining the end points of the arc AB with the points P, Q, R, S. So AB points keeping same. From A join AP and also PB. From Q, AQ, QB. From R, AR, RB. From S, AS and SB. So AOB is equal to 2 into APB, AOB is equal to 2 into AQB, AOB is equal to 2 into ARB, AOB is equal to 2 into ASB. Now what we can say, how we got this one? Angle subtended by an arc at the center is twice the angle subtended by it at any other point of the circle. These are all the angles. Angle subtended by an arc in the same segment are equal. Now let us see concyclic points. In this figure, the points P, Q, R and S lie on the same circle. Then the points lying on the same circle are called concyclic points. Now what is a cyclic quadrilateral? If the vertices of the quadrilateral ABCD lie on the same circle, then the quadrilateral is called cyclic quadrilateral. So if you observe this, ABCD is a quadrilateral. Then what is the theorem? The opposite angles of a cyclic quadrilaterals are always supplementary. Now given ABCD is a cyclic quadrilateral, what to prove? We should prove A plus C is equal to 180 or else B plus D is equal to 180. Angle D is equal to 1 by 2 angle Y, and also angle B is equal to half of X. So by adding equation 1 and equation 2, what we are getting is angle D plus angle B is equal to half into angle Y plus half into angle X. So that we can write half into, if I take half common from here, angle Y plus angle X. So angle D plus B is equal to half into 360, which is 180 degrees. Similarly angle A plus angle C is equal to 180 degrees. So therefore we can say the opposite angles of a cyclic quadrilateral are supplementary. If the sum of any pair of opposite angles in a quadrilateral is 180 degrees, then it is cyclic. So let us take one note here. A cyclic rhombus is a square. A cyclic parallelogram is a rectangle. So what is a cyclic rhombus? If 4 vertices of rhombus lies on the circle, then definitely it must be a square. And also if 4 vertices of parallelogram lie on the circle, then definitely it must be a rectangle. So what we have learned, students? We have learned perpendicular from the center to a chord and also circumcircle, angle subtended by an arc of a circle, cyclic quadrilaterals. For better understanding of the concept, solve the worksheet. Please visit the official website SCRT for worksheets. Thank you. Thank you for watching. Thank you, students.
सभी अध्यापकों को मेरा नमस्कार और छात्र छात्राओं को शुभाशीष। आप सभी का स्वागत है नवीं कक्षा की हिंदी डिजिटल कक्षा में। बच्चों, पहले हम एक वीडियो देखेंगे, उसके बाद में आज की कक्षा का आरंभ करते हैं। तो देखिए पहले ये वीडियो।
सवेरे सवेरे यारों से मिलने बन ठन के निकले सवेरे सवेरे यारों से मिलने घर से दूर चले रोके से ना रुके हम, मर्जी से चले हम, बादल सा गरजे हम, सावन सा बरसे हम, सूरज सा चमके हम, स्कूल चले हम, स्कूल चले हम। दरवाजे से दुनिया के राज खुलते हैं, कोई आगे चलता है हम पीछे चलते हैं, दीवारों पे किस्मत अपनी लिखी जाती है, इससे हमको जीने की वजह मिलती जाती है, रोके से ना रुके हम, मर्जी से चले हम, बादल सा गरजे हम, सावन सा बरसे हम, सूरज सा चमके हम, स्कूल चले हम, स्कूल चले हम।
तो चलिए बच्चों, आज की